Hi everyone, my name is Nina and I have been assigned the Santa Ana winds for my video presentation. We learned about them in class, but I hope that by the end of this video you guys feel just a little bit more reviewed and just overall have a better understanding of what they are, how they work, and also some impacts that they have as well. Okay, so to start up, I just made this little slide to look at what I'm going to cover today. So first up, we're going to talk about what the Santa Ana winds are, as long as look at a little visual aid. We're going to talk about where they come from. And one of the most important parts from today's video is we're going to talk about the physics of the winds themselves and how they come about, how they move and such. We're going to talk about why humidity drops, and then we'll end with talking about wildfires and other impacts as well. Okay, so first up, what really are the Santa Ana winds? So, by definition, the Santa Ana winds are very strong, hot, and dry winds that blow from inland deserts towards the coast. So they are more moving towards our coast, so they are moving westward. They are most common in the fall and in the winter, and the wind speeds themselves can actually exceed up to 70 miles per hour, which I think is absolutely insane. Because these wind speeds can get so high, they are a huge contributor to Southern California wildfires and wildfire outbreaks as a whole. Okay, so you are more than welcome to screenshot this, pause it and look at it, come back to it later, but I found this little diagram picture online that I thought could be really helpful just to show the little steps and how they travel, and I think over here it shows a nice little arrow direction of how these winds are moving westward towards our coast. Okay, so where do these winds come from? So the source region themselves is called the Great Basin. I hope I'm pronouncing that okay. It's kind of where Nevada, Utah, and Eastern California overlap a little bit. Not that Eastern California and Utah overlap, but this general direction over here. Their destination, if you will, is the Southern California coast. And the land features themselves that they kind of travel through and to are the San Gabriel Mountains, the San Bernardino Mountains, and the Santa Ana Canyon. Okay, so this will probably be the most important part of today's video. We are going to talk about the process and the physics themselves, the physics itself of the winds. So first, I'll just walk us down the line. First up, there is high pressure inland and there's low pressure at the coast. So this high pressure develops over the elevated deserts inland. And near the Pacific coast, there is lower pressure. This overall pressure contrast creates an offshore pressure gradient that pushes the air westward towards the ocean, so towards the coast. The air starts out very cool and dry. There is this overall assumption that these winds start off so hot and heavy, but to break that assumption, they are actually really cool and dry, and that's how they start off. Don't get me wrong, they definitely will talk about that they warm up a little bit later in the process, but just make sure you understand that they do not start off warm, and they start off as relatively cool, dry air hanging over the high elevation deserts of the Great Basin. So, as I mentioned, during fall and winter. There is descending air that warms up by compression. So this is when we get to the warming. So as the air descends from the mountains towards sea level, the atmospheric pressure is actually increasing. So that surrounding atmosphere compresses that descending air. So the compression, as it's compressing the descending air, increases the air's temperature, even though, don't get this confused, even though that there's no actual heat being added from outside. It's just that compression that's increasing the air's temperature. Then, this is when the air becomes extremely dry and the mountains accelerate the wind to become so fast and really pick up speed. So its capacity to hold water vapor increases. And the actual amount of water changes very little. So it's something I pulled is that it doesn't change so much. The relative humidity therefore drops dramatically, and as it travels through the mountains, the airs pick up a lot of speed and travel a lot faster and stronger. Okay, here's just a little chain reaction diagram situation. So we started off with the high pressure over the Great Basin, then we go to the mountains, then that compression of the air, and then that becomes hotter and drier air, and that eventually travels all throughout the mountains and the narrow passages and ends up in SoCal. Okay, so why does the humidity drop? The humidity drops because the warm air can hold more water vapor, but the actual moisture content doesn't change very much, like I mentioned on the 2 previous slides. It stays nearly the same. So, like we learned with our little equation in class, when the temperature increases as well as the pressure increases, the relative humidity will decrease. Okay, so just to wrap up today's video, we're going to look at some impacts of the Santa Ana winds. I would say from what I found, the biggest one are wildfires. These winds themselves just bring an overall faster fire spread, longer flame lengths, and just a really difficult time for firefighters to stop them in a quick amount of time. In terms of environmental effects, dust just transports a lot more and a lot faster. There's an overall poorer air quality and a really big damage to trees. For human effects, all these above affect us, but this results in power outages, road hazards, and property damage. So that is all that I have for today's video. I hope that now you have a little bit of a better understanding of the Santa Ana winds and how they work and some of their impacts. Happy week 10 too. Everyone has got this, all this studying. I hope that you can take this Santa Ana wind knowledge with you inside and outside the classroom, especially for our exams and just our overall understanding of this quarter. But thank you so much for watching, and that's it.